name's Gary Park. That's all my contact details there. I'm here to talk to you today about a product or a tool known as GitVersion, which helps you do semantic versioning of your application or your library. So full disclosure, I'm a contributor to the GitVersion project. It's an open source project hosted on GitHub. So if anybody's interested in helping out, you certainly can get involved. I work for a company called DEI up in Aberdeen, working in the offshore oil and gas industry predominantly. And I'm also co-founder of the Aberdeen Developers.net user group. So if anybody's up in Aberdeen, we try to run monthly meetings. So I'd encourage you again to come up if you can. So the rough agenda for today is to find out what is GitVersion, and then in order to understand what semantic versioning is, and then have a look at why you want to use GitVersion and then how you can get used to it, how you can get involved with using it. And then at the end, assuming that the demo gods are favorable, I'll try and do a demo of GitVersion as well. So the first question is, what is GitVersion? GitVersion, by definition, is a tool that will help you to achieve semantic versioning of your application. So before we talk about semantic versioning, what it is and what it means, I want to provide a little bit of history about GitVersion because it's had quite an interesting history and it's evolved as it's gone. So GitVersion is essentially, it's an exe that you run against, understandably, your Git repository. So it kind of assumes that you're using Git as your source control system. There are murmurings that we could use other source control systems like Mercurial and so on, but that's forward facing. At the minute, it's focused on Git. It's a tool that started out actually as two tools. There was two different people, one an organization and one an individual who was creating it. The first one was Particular Software, who created a tool that was predominantly focused on the GitFlow version, branching strategy. And another guy called Jake Ginnivan was creating another tool that was focused on the GitHub Flow branching strategy. So for those of you who don't know, within Git, you use branches a lot, and there's two different main strategies. One is the GitHub Flow, and one is the GitFlow. We're not going to talk about those too much today because they're a whole topic in of themselves. If you're interested, I'm happy to bend your ear about it, so come and talk to me afterwards. So we had two tools that were going off in two different directions, and it quickly became apparent that they were doing lots of the same thing. So what Particular and Jake decided to do was to create one tool. So rather than having GitHub version and GitFlow version and all these other tools, it became just GitVersion. So the focus of GitVersion is to assert a version number by looking at your commit history within your Git repository. So rather than use any sort of external tools, it focuses just on the commit history in your repository, and it can assert a semantic version number for you based on that commit history. So we'll dig into that in a bit. So now that we kind of know what GitVersion itself is, what we will need to focus on what is semantic versioning and why we want to use it. So again, semantic versioning by definition is a simple set of rules and requirements that dictate how a version number should be incremented. It's a philosophy that was put forward by, I always forget his name, Tom Preston Werner, who was the co-founder of GitHub and the creator of Gravatars. So what he's put in place, it can be thought of as a standard, but it's not a full standard. It's a set of rules that say when you increment your version number. It's a definition of, it may well possibly just be a standardization of what you're already doing. But it's, as long as we all follow it, we as application developers and tool creators, it provides the ability for consumers of your application or utility to understand what's happening within the next release of your product. Okay? The full definition of the standard is available on semver.org there, but what it's trying to prevent, or what it's trying to stop you falling into, is two things. One is version lock, and one is version promiscuity. So again, those are two terms that we're not going to go into too much today. Again, they're wide and varied, and I'd encourage you to look into it. But essentially what semantic versioning is trying to prevent is, or it's trying to prevent you from buying into one piece of technology and taking a dependency on it, and then as a result of upgrading that piece of functionality within your application then breaks. So as long as you can look at the semantic versioning of an application, you can be more confident in taking the upgrades because you know what's contained within it because of the use of semantic versioning. Hopefully all that makes sense. If not, feel free to ask any questions as we're going through. So what are the rules and what are the requirements of semantic versioning? A semantic version is made up of 3 different parts. You've got your major, your minor, and your patch number. If you're in a .NET development house, you may well think that your version number should have 4 parts because that's what you've got in your assemblyinfo.cs or your assemblyinfo.vb file. Yes, that's true. Microsoft think we should have 4 version numbers. The last one is the actual build number. Semantic version doesn't really use it, and we'll get into that in a bit and how GitVersion kind of helps with that. But what semantic versioning provides is an additional set of metadata that you can extend onto the end of your version number that provides kind of that information that the build number within the Microsoft definition provides for you. The important parts here is that as you're incrementing or changing your version number, only one of these numbers should be incremented at any one time. So if you are making a fundamental breaking change to your application or your product, you would increase the major version number. So you would go from 1 to 2 and so on. The reason being that someone looking at your version number could then understand that something in your product has a non-backward compatible change. You might extend a method by including additional parameters. You might provide new functionality that breaks other functionality. So looking at a version number, you can say, okay, that's a major version change. I'm not going to pull that version in straight away because I know it's potentially going to break stuff within my application. Incrementing the minor number has an impact of basically saying to someone consuming your product that we've added new features into this application, but we haven't actually broken anything. So we're providing new features, but it'll still continue to work. So you've got a little bit of reassurance there that it's going to continue to function. And by incrementing the patch number, you're saying to someone that there's been no new features added, there's been no breaking changes, all we're doing is fixing bugs. So those are kind of the rules. And what happens is that if you increment the minor or the major, the numbers to the right-hand side always revert to 0. So we start again, basically. Okay, so some example version numbers, just to kind of drill home the point, that would be the first version number that you work towards. You might think it might be 0.0.1, but 0.0.1 would indicate that you've provided bug fixes. How can you provide a bug fix on something you haven't actually made yet? So the first semantic version that you work towards is 0.1. Okay. Following that, the next one that you might have thought it would be 1.0.0. The reason that it's not that is because that's what you want to make your public-facing first version, because that's the one that people can take a dependency on. Once you've got to 1.0.0, what you're saying to consumers of your application is that the surface area of this product or this application is fixed, and it's not going to change within this major version of that release. If something does cause a breaking change, you would up to the 2.0 version. So just to drill this home a little bit more, what we've got here is a semantic version that's basically saying there's been 3 minor releases of this, and on that 3rd minor release, there have been 13 bug fixes contained within that. So as I mentioned before, semantic versioning provides the ability to extend the version number with additional sets of metadata. So what we're seeing here is that this is the 2nd minor release, or we're working towards the 2nd minor release of our application, but we've got some additional metadata that maybe says unstable. So this is where you can start bringing in things like an alpha, a beta, an RC nomenclature to indicate that you're working towards the beta release of your minor version. And the 3 in this case could be, we've made 3 commits into our repository. But by extending the metadata, you're again providing consumers of your application or product information about the current state of it. And then semantic versioning can get really, really scary, right? So this is a perfectly valid semantic version, but what it's doing is, it's extending the metadata. So what you've got here is lots more information. What you've got is here, This is the branch that the commit came from. So we're on the develop branch within your repository. And this is the full SHA-1 hash that uniquely identifies that commit within your Git repository. So you wouldn't necessarily want to make this public because no one really cares. But developers and other consumers of your application may need this in order to trace back through the commit history to indicate where something got changed or how something got modified. By adding it into the version number, you provide that ability for them to go back in time and see what's going on. Okay? So hopefully we've got an understanding of what semantic versioning is, why we want to use it. So why would we want to use something like GitVersion? If semantic versioning is only about incrementing version numbers and making a few changes here and there, why would we need a tool to do that for us? Why can't we do that ourselves? When you do it yourselves, you might have some existing versioning strategies. One of these might be to have this version.txt file within your repository. I know that I've done this in the past. The idea here is that your version number is contained within that version.txt file. And then something within your build process will read the contents of that file, use it as part of the build process. Problem with that is a developer has to remember to do it. And also, it doesn't really scale very well if you start looking at the branching strategies that I mentioned earlier with GitHub Flow or GitFlow. Your different branches would have the same version number contained within them, so you have to update them separately within your separate branches, which is not ideal. Another strategy might be to use something like a continuous integration server. So this is a screenshot from TeamCity, which some of you might be familiar with. What this is doing is using the actual build counter within TeamCity. So every time TeamCity runs a build, it increments its own internal counter that says this is build 1, build 2, build 3. So you can actually use that number and append it into your version number. Again, perfectly valid strategy. The only problem that I see with that one is it's got a sort of vendor lock-in. You're locking then into the TeamCity build system. Now, although you could take that build number and transport it over to another system like Jenkins, you may well start doing something specific to TeamCity. So my advice is that you don't necessarily want to lock into something that's specific to one particular vendor. You want to keep your build and your versioning strategies as agnostic as possible. Another strategy might be to manually update. This is a screenshot of an assembly info file. So again, updating manually the assembly info files contained within your project. It suffers from the same problems as the version.txt file, that someone has to remember to do that. Another strategy is you just don't care. You don't have a versioning strategy currently, so GitVersion can kind of come in and fill that void for you. So how do we get started with GitVersion? GitVersion is just an exe that you want to have on a system that you want to run it on. So it's really simple to get installed. You can use Chocolatey. Anyone familiar with Chocolatey and know what it is? 3 or 4? Okay. Full disclosure, I also contribute to the Chocolatey project, and I think it's great. Chocolatey is a package manager for Windows. If you're used to something like apt-get or yum or homebrew for Linux and Mac, then Chocolatey provides that functionality for a Windows ecosystem. You can literally, at a command line, do one command, which in this case is choco install gitversion.portable, and it will go off to the internet, download that exe, and install it onto your system ready for consuming. You can also use it as, there's also a NuGet package, which is just the exe. You can add that as a solution level artifact into your project and just consume the exe directly within your project. There is an MS build task if you like MS build. Anyone who does is a braver man than I am, or woman. There is a task there, and it will automatically inject itself into the pre-build pipeline of your MS build. The other way is a Ruby gem. I know nothing about Ruby, so please don't ask me about Ruby and how it works. There are other people in the conference who know more about Ruby, so ask them. The Ruby gem is just a wrapper around the GitVersion exe. So if you want to use it there, feel free. So what does GitVersion give us? GitVersion gives us, by default, that. So it's a JSON structure that is a set of variables that has asserted, based on the commit history, the current version number of the repository. So all I've got here is, this was a brand new Git repository that I created, and I ran GitVersion on it. So by default, we're working towards the 0.1.0 release. And what we've got here is the individual portions of that version number. So if you're interested in the major minor patch, you can use those. But more interestingly is it's got the full metadata and the SHA-1 hashes and the branch names. So all of that information is available to you as part of your build pipeline. So if you wanted to use specific pieces of that version number, or use that directly when you're packaging your NuGet packages, or whether you're bundling up your package, your application into an MSI, you can start using all of those variables directly just as part of your build process. So you might be thinking though, well, how does that help? Because I've still got stuff I need to do. So having run the GitVersion.exe, I've just got a JSON structure. That doesn't really help me. So where GitVersion really starts to shine is when you embed it within some of your existing build pipelines. So out of the box, GitVersion supports Visual Studio Online, which is Microsoft's TFS in the cloud offering. It's not the TFS of old that some of you might have used. It's actually quite good. Also supports things like Octopus Deploy, Jenkins, AppVeyor, Bamboo, TeamCity, Continuous CI, and MyGet. So all of these build servers have the capability of running GitVersion. So what GitVersion then actually does when you use it in this scenario is that it will take those JSON variable structure and it will create environment variables as part of the build process. So within the additional build steps you might have within TeamCity or Jenkins, you can start to consume those version numbers as just the environmental variables that have been created for you. So what I'm saying here is that it doesn't, adding GitVersion into the pipeline is really simple because it just extends the existing functionality that you may already be using. So rather than using, say, within TeamCity, the build counter and into your build format, your build version number, you can just start using GitVersion and exchanging the environment variables that are used there. In addition, GitVersion also starts to update your assembly info files. So out of the box, it can start taking those variables that have been created and auto-updating the assembly info files as part of your build process. We are, at the minute, focused kind of on Windows development, so if there are other files that need to be updated, those need to be done manually at the minute. So, short of having any questions, I wanted to go into a demo, because the demos can be quite interesting. So, before I jump into that, is there any questions before we start? If not, I'll take them at the end. So the demo that I'm going to show is based on, if I just close that. Good. Okay, so what I've got on the right-hand side here is a tool called SourceTree. I don't know if anyone's familiar with it. SourceTree is a tool for working with both Git and Mercurial repositories. What I'm going to show here is a repository that I've set up that's set up to use the GitFlow strategy. So GitFlow, by definition, has kind of two working branches, a master branch and a develop branch. All the main work is done in the develop branch, and once things are ready via, say, feature branches, you would then push that into your master branch, ready for creating a release. So GitVersion automatically knows about all of those things. So on the left-hand side, if I just run GitVersion, if I can type it, what we're going to have there is asserted those version numbers. So again, that's just what I showed in the screenshot before. We're working towards the 0.1.0 release, and we're on the unstable develop branch. Okay, so what I'm going to do just to show how things start working, this is the readme.txt that I'm going to be editing, so there's no code involved here because live coding is torturous at the best of times. What I'm just going to do is make some modifications to that one file. So what I'm going to ask you to do is use a little bit of imagination that this is we're actually working towards some code release. So this is going to be our first change. So I'm going to jump back into SourceTree, which will allow me to do a commit of that file. I'm not going to worry too much about the commit comments just now, but by going back to GitVersion and re-establishing GitVersion, what you'll see here, hopefully, is we're now one commit along. So if I get out of the way a little bit, what you're seeing here is we've moved along one commit. So before we were there was no commits in that repository. We've now moved along and we're now at the next release. So GitVersion looks at your commit history and it uses commit counting because it needs to establish that this is a modification that you've made. So it's going to use the commit history since the last tag in your repository, and it's going to use that to count them along. So if I show that again and just make another change, again, it doesn't really matter. And let's just do a commit here. So again, it's committed, and it's now progressed that version number along to number 2. So again, you might be thinking, why? What does this really matter? The real power within GitVersion comes when you start using the full GitFlow strategy. So if we go into source tree here, and what I'm going to do is I'm going to start a new feature, and we'll just call this feature 001. Actually, we'll call it feature 1. So within GitFlow, what you're doing then is you're kind of taking a branch for doing a logical piece of work. So you're going to do all that work within that feature, and then you're going to pull that back into the develop branch. So if we go back to our markdown pad here and say this is us working on feature 1, and we'll just commit that into the repository. Then what GitVersion is going to do is it knows now that we're on that feature branch. So it's established that we're on the branch called feature 1 that we haven't necessarily, it's continued that commit count as well. So it's now 3 along because we've got 2 in the main trunk, and then we've got another 1 within this feature branch. So what this allows us to do is start having different trains of development, all being pushed to maybe a repository, or rather an artifact directory where you're consuming them for testing purposes, but you're able to uniquely identify each of those version numbers just by using GitVersion to establish that version number. So if we follow through with the GitFlow and we'll finish that feature, we'll just push that into the develop branch. So again, if I run GitVersion, we're now back on the develop branch, and we're back on the unstable release of that product. So it's now lost the kind of feature branch nomenclature because that feature has effectively been closed off. So then within GitFlow, what we do is we start to create a release. So again, we're working towards this 0.1.0 release. So we want to start moving that into our master branch because the master branch is where we're actually going to deploy from. So if we go ahead and start a new release, and we're going to say we're working towards the 0.1.0 release, and then in here, this is where you might start adding some release notes. If we go ahead and commit that into the repository using source tree. And then we're going to run GitVersion again. So it's going to know now that we're no longer on the unstable version. We're working towards the beta version. The idea there is that we know as developers that we've created that release branch because we're working towards that initial release. But GitVersion has also asserted that for us. Again, just based on the commit history that you have got within your source control system. So it's the beta release. It's 4 commits ahead. And it's still retaining all the SHA-1 hashes. So again, from that, if you're using that to stamp your MSIs or your EXEs, you know exactly where it came from, and you can look back in your source control to find out what was going on. So if we finalize that release, pushing the change into master, what we're going to get, if I jump onto the master branch, so what we've got here is we kind of start losing some of that build metadata now. Because at this point, we're in the master branch. That's the master branch that we're deploying from. So the semantic version now is just 0.1.0 because that's the version that we have released onto that branch ready for deployment. So you still got the full master branch, the full build metadata where the SHA-1 hash is, but you lose the unstables, you lose the betas because we're no longer at that stage. Again, GitVersion being used to establish that. And the final part of the GitFlow is the creation of a hotfix. The idea of a hotfix is you're on the master branch and you've pushed it onto the production servers or you've deployed it to the public and there's a bug straight away. So you don't want to wait until the next release of your minor release or your major release. You want to create a hotfix. You want to release that just as a patch release. So what you can do within GitFlow is this concept of a hotfix. So we'll just go ahead here and say that we're working on hotfix 011. And we'll just jump back into here and say that this is our hotfix. And if we go ahead and commit that into the repository, then we're back to beta. Because we're on that hotfix branch, we're now back to a beta stage, but it's a beta of the 011 release. And we're one commit along because we've only made one commit. And if we push that back into the master branch and tag it with the 011, then we'll be back out of the beta stage. And we'll be back on the master branch. We'll run GitVersion. We're now out of the beta stage. We've released that onto our master branch ready for consumption, and we've now got a semantic version of 011. So what I'm hoping I've showed you here is that in quite a short space of time, using GitVersion, I've established solely based on the commit history in your repository that it's possible to assert the version number. We as developers don't need to worry about what version we're at, what version we're going to. By using a branching strategy, which in today's world of Git and GitHub, it just makes sense. By using pull requests within your source control system and allowing code reviews that go with it, a branching strategy just makes sense. The GitFlow branching strategy is somewhat more complicated than the GitHub flow, but for what I use internally, it makes a lot of sense. Especially if you want to support multiple different versions of your product. And adding something like GitVersion into the mix just makes it easier. Again, that's my opinion. I'm hoping that I've convinced you that that makes sense as well. So now that that demo went better than I hoped it was going to, let's get back to our slides. So do we have any questions? Sure. Good question. So you can do that through a couple of ways. The way that GitVersion works, it asserts the version number based on 4 or 5 different things. One of those is it finds the last tag in the repository, and it uses that as the base version, and then it can calculate from there. But it can also use commit messages. So if, as part of your commit into one of your branches, you know that you're making a non-backwards compatible change, then you can write that into the commit message. So there's a standard convention that's in the documentation that allows you to bump that major version as you go. The other one is GitVersion out of the box just works, but some people don't like the way it works and want to configure it. So there's the ability to create a GitVersion YAML file that becomes part of your repository. And in there, you can actually stamp what the next version is that you're working towards. So if you know that you're working towards the next major release, you can actually put that into that YAML file, and it will use that as the base version for calculating the sender going forward. So yes, good question.
So you said there's a convention that it can just pick up from the commit message that this is a breaking change. Is it just something like if somebody puts in a commit that's a breaking change, it will then
the out of the box one is, I think it's like plus semver or something like that, but it's just based on a regular expression. So again, I'm fairly sure that within the GitVersion YAML file, you can specify what the regular expression is to look for within the commit message. So if you wanted to have something that was specific to how you operate, then you can look specifically for that within your commit messages going forward. So yeah. Okay. And okay, we'll go over here first. Yes.
Is it always dependent on you tagging it with the right version, or could you like jump backwards and tag it with like 0.1 when you've already done 0.2? Will it get confused?
So the question was, or to reword the question, can you break it? Yes, you can. If you create a tag incorrectly, it's got the wrong tag, and it starts using that as the base version, then the asserted version number is going to be incorrect. At that point, you could delete the tag and start again, or you could start using the GitVersion.yaml file to provide the base version number, because it's based in a hierarchy. So in order to assert the base version number, it goes through all of those steps and then takes whatever it's found as the base version number. So there is an element of process and due diligence that needs to go with this, but that's no different to what you'd have to do anyway. So if you're tagging things with the wrong version number, you've got bigger problems as well. It's not going to be just GitVersion, but yeah, you're right. It's not going to help you in that sense. No. Yes.
Yeah, mine was a similar kind of break it question.
Yeah.
And also, I just want to check, do you have a Linux and Mac version?
Good question.
But my breaking bit was,
yeah.
If I was, because you checked out the hotfix and put the hotfix number in there. If
yep.
I then had halfway through working on that, I had a hotter fix and I needed to stash and create another hotfix, is that something I have to sort out manually afterwards?
So the way that GitVersion works and the way kind of GitFlow works, it's kind of assuming that you're working towards that next release. So if you have a hotfix in flight and you have another hotfix, why would you not just put it in that same hotfix release? Because you're working towards that next release. Unless there was some delay that was causing or going to be caused within that first hotfix branch,
yeah.
Why not?
It's going to take me a day, but the other one is like a typo or some issue, and it needs to be done now because.
I'm fairly sure that we could handle that, but I don't want to commit to that on video. So you come back to me and we can figure out what would happen in those scenarios. I'm fairly sure that we could handle it. Yes.
Presumably, until you've merged it back into master,
you're not going to create the tag. Until you've merged it back into master, you're not going to create the tag, so it's not going to use that as the base version number. So you have got an opportunity there to specify what that base version would be in other ways. So you could probably get around it, yes. Even though your branch might be called 011, but it's actually moved 012, you could probably get away with it just by using the tag. And in terms of the Linux and Mac support, it's a very good question, and it's one that we've been asked before. GitVersion at its heart uses libgit2 sharp, which is the .NET native implementation of the libgit2 libraries, which is the C implementation of how to talk to Git. So long story short, libgit2 fully supports Mac and Linux. GitVersion currently doesn't, but we have now got initial support for building on Mono, which is a good step towards being able to run on Linux and Mac operating systems. So it is something that's in the pipeline because it is something we've been asked about more and more. Yeah, certainly. Any other questions? Yes?
Excuse me, you mentioned Visual Studio Online, but is it fairly easy to integrate with TFS?
There is TFS support as well, so you could do that in a number of ways. TFS likes MS Build, so probably the MS Build task would be the first one, but it is just an EXE, so whatever your pipeline looks like, assuming that you can run that EXE as part of your build process, it'll continue to function, yeah. The MS Build task will probably be the best one in a TFS environment. So that's just some documentation and resources that you might want to follow. I'll put these slides online somewhere, so if you want them, just shoot me an email or tweet me. What I was asked to mention was there is an open space board upstairs. The idea is that later on today there's going to be an open space discussion sessions, but in order to know what people want to talk about, they want to know what you want to talk about. So there's a bunch of post-it notes. The idea is you write on what your topic of discussion would be, and you can put it on the board, and then we can decide as a conference what we all want to talk about, and then there's an open space session to do that discussion later on. So that's me. I have nothing else.